Alright, so this week I did the physics project and I kind of might have done a little bit of unnecessary work, but I'm not sure if that's the case. Because I didn't use everything I built, unfortunately. I should have, but I didn't. Um, so to start off, I am looking in the wrong place, I think. Yep, here it is. Okay, so I created a dynamic physics object that I'm inheriting from. This one is also kind of functioning as the cube or box collider version. I'm planning on, well, if I continue to develop this, I would overload it to be like a specific one for a box, because this one also doesn't have mass or anything. It's all just mass is one, um, or like the default. Um, so same thing that we always do when we overload or inherit from a world object, the new and set position. This one is pretty cool because it not only sets the position of the graphical body, but it also sets the transform or the position of the physics body. And then why don't we just go through this? On create calls the world object on create, and then it does some. I'm just using these. I also would like to. I would probably create a whole struct that has all, or maybe even a whole class, depending, that has all of the different configuration stuff that I would want in it, like what the material information is that I'd want, and the types of geometry that I'd want, and all of that. So, and then this one is a rich dynamic, and it is, like I said before, just like defaults to box. And then to sync the pose, we get the pose from the physics, convert it, like with the code that you showed us or that was in the slides, and then we set the pose. And then apply force is just a way for us to call the physics by using it through the world object and add the force. And it's kind of a, I don't know, maybe this isn't a good way to do it, but I have it kind of doing two things. Since the physics wants a direction with a magnitude all built into one vector, they don't want like a normalized vector. They want it all, the magnitude is the strength of the force, and then the direction is the direction of the force. So you could do that if you don't give a force strength. Like, for example, if you had, like, if you knew that your magnitude was the amount of force that you wanted to apply, you could just pass this in, and this is default to 1. But if you had a normalized vector and you just wanted to do a direction and a force, you can pass in the force direction and keep and the force strength, like the amount of newtons. So and then because it defaults to 1, if you pass in the one with the magnitude, it's an identity. It's the same thing, so it doesn't matter. This does nothing, but it's there, so we don't have to write two functions for it. I guess I could. It wouldn't matter. Probably better to have it separate so that it does one specific thing. And then I made a dynamic sphere, which actually just inherits from that. So it, again, has the new and the on create. Let's find and then this, it only really has one difference, which is it uses sphere geometry. And I don't know exactly why, but I was having trouble getting the radius of the sphere to match up with like the radius of, I have a planet in my thing, and I was having a hard time getting it to match up to the scale like 1-to-1, but I don't know, I could be just completely off on how I'm trying to do that. I thought it was 1-to-1, like 1 meter in, or 1 unit in Afterburner was 1 unit in PhysX, but maybe I'm wrong on that. I'm not 100% sure. And then let's go into here and show you what I added. We do some initialization down in the load map for the, I put it in a function. That way I can change it, super easy. Initialize the physics engine, doing all of this. And then I'm kind of, I don't want to say cheating, but I'm kind of cutting a little bit of a corner here by having the center of the little orbital system that I built just be like hard coded into the initialization. If I was gonna do this, like if this was gonna be like a full-on semester-long project, I would definitely not do that, but I figured it was fine for this. And setting the gravity to 0, 0. So I did try the gravity with like negative after gravity right here, and everything fell down, and that was fine. But I was trying to do like a little solar system, so I would set it all to 0 just to make sure. I don't think there's anything else in here that's super interesting. A little script to update the physics objects. I just have it hard coded to be 0.2 seconds or 0.02 seconds, and I got that from Unity. They do physics time steps as a 50th of a second, so I'm used to that. So, pretty much copied this from what you had for what was in the slides. That's not mine. And then I wrote this to apply a gravitational force to each of the cubes that I have. And it just takes a dynamic physics object and another world object to orbit. And right now it's hard-coded that it's gravity. But if, like I said, if I was going to do this longer term, I would want it to be like the actual proper gravity equation, like the gravitational force equation, whatever that is, m1, m2 over, I don't know, distance between the centers of mass. Something like that. I was looking at it earlier. And then I'm creating a couple cubes here, and then I apply an impulse to them right here to get them orbiting. So, and then I already have this set up, and this is like this doesn't have any of the physics running on it. I mean, as you can see, they're just static right now, and nothing is happening because there's no physics. But it's listening on the network port. So as soon as I start this, you'll see them move, and then I'll have to move the other camera to like get a good view of what's going on in the other window. So let's open that up. Okay, there we go. And oh yeah, I guess it pauses when you move things. That's neat. So yeah, you can see what's going on here. So yeah, they're just orbiting in like one's at I put off kilter, that way you could see that it wasn't like anything. I think that this orbit might be not stable. I didn't let it go for very long, but I think it might eventually decay into colliding with this, the sphere in the middle. But to speed that up, instead of like waiting to see if that happens, I'm gonna just change it so that they don't have that impulse. And I think actually it will snap these guys, the listeners, over to wherever they start, whenever that happens. So I'm not sure if that's true, but I suppose we'll see. I haven't tried that, but I'm guessing that's how it works. 0 and 0. So go ahead and open this up and press play, and then open it up again. Yep, that's exactly what happened. So yep, and then see they collapse, or they fall right onto it. And I guess I should have made the Earth slightly bigger. These cubes are pretty big comparatively, but you can see like they're synced perfectly. See, this is what I was talking about. There's a little bit of a a little bit of overlap, but it. I set it to 1-1, and it was terrible. They were like the cubes were all the way inside, and then I had to. So I was trying to tweak the collider size. I don't think that's what they're called, but the box geometry size to be exactly right. But I must be off a little bit. Maybe it's because this isn't radius 1. Maybe that's like the text, not the texture, but the model I imported isn't radius 1. That's probably what it is, and so I would have to find a way to figure out what its radius is, and then that would be what I would set the collider radius to. So yeah, that's it. So unfortunately I didn't use the dynamic sphere because this is just static. But I built it and I did test it, but I didn't use it for this just because I wanted it to be stable enough that it could just stay still when I wanted it to and not immediately get thrown out. And I didn't really have, I wasn't really sure how to fine tune the masses for everything, so I just left it at this has infinite mass. Well, not infinite mass. It has enough mass to give it standard Earth gravity to these guys, so pretty dense for this little guy. I think that's everything. So let me see if I did anything else cool. Did I do anything else cool? Doesn't look like it. So that's it.